way that this panel is going to work is we are here to answer questions about CAD and hands-on design. So we don't have a structured presentation for you. Your questions are welcome. We have some stuff we can show you, a lot of examples, a lot of things we can talk about. But just to get started, does anybody here, is anybody on the Discord that has seen what we do? Sort of a few people. So my name is Jameson. This is Jackson and Julian. We're all from Project Peacock. Julian and I are part of an international CAD team called the Looney Squad. We do a lot of off-season CAD designs, a lot of crazy, wacky stuff to kind of push the boundaries of what's possible with FTC design. And you guys got to see some of that in our robot last year. It was rocker 8-wheel drive and a double jointed turreted arm. You know, you saw it. Does anyone have any questions from that robot? I think that's a good place to get started. Did that robot have any unanswered questions from last season? We don't have it with us today, but
yeah, I think if we had it with us, that would probably be a better thing to start with. Yeah, so we could just cover
just run down
having a competitive design process and all that.
okay.
Okay, so
Just run down all the cool things that you think are interesting.
I'm gonna I just lecture better when I just walk around. So last year you might have noticed there were a lot of teams that were able to okay, show of hands, who all was doing FTC last season? Okay. All right. So last season, you might have noticed a lot of teams that were able, had a super optimized path. So there's the field, there's the barrier. There were a lot of teams that were able to just shoot through here, extend an arm out, and then go back. And basically, that part of that was due to heavy amounts of path optimization. So basically that's where you start with a competitive design process. We just wanted to build a cool drivetrain pretty much, and that's where we started. So we just went straight over the, that's the eraser. So we just went straight over the bars because, why wouldn't we if we'd always wanted to do suspension and stuff, and that sort of thing is okay. But yeah, I have 14 of these packets. If you're in the post, please don't take one. Because I can just print them out for y'all later. But this starts out with notes that you can take on all the points during the kickoff video. You just jot down the scoring methods and then the points, and then afterwards you can decide what priority you have for each challenge. This is really important if you want to have a super competitive timeline. You can know your limits and everything. Then you draw the field on each of these doodly bops here, and then you decide what path you're going to take. Note that arms and stuff can shorten your path if you do it right. But then we have more of those. It's good to draw 4 different paths so you know which one to take.
You might hand these out before you go through and explain it so people can see it better.
Yeah, if you
This is why
want,
Jameson needs to do different.
if you want one of these, raise your hand. I don't have very many. Okay.
So Julian has brought up a good point about the beginning of the design process. So the first step of your season of designing your robot should be analyzing the game. So there are 2 parts to that, and that's a score breakdown where you can go through and write out all the ways you can score and the amount you can score from each of them in each part of the game, so in autonomous, teleoff, and endgame. And then reading through both Game Manual 1 and Game Manual 2 to make sure you're very familiar with the rules, because in our experience it's really easy to come up with designs that are accidentally illegal.
Yeah.
A good example of that last year is our belt. So our robot had a big timing belt on the front of it to spin the ducks off the carousel, but that started as Andy Mark blue nitrile tread, which is universally illegal. We made an assumption though that because it wasn't touching the field, it wasn't a problem. The reason that's illegal is it tears up the field tiles. Ours was not touching the field, we assumed it was legal, Ingrid told us it wasn't, and so we had to go back and redesign after we spent a bunch of time on that. So familiarizing yourself with, especially Game Manual 2 is really important. That is where all the design begins, and you can do that today. As soon as we get the game reveal video, they'll post Game Manuals 1 and 2, and I'm sure that Travis will send something out about that on the Discord, which if you're not on the Discord, come and talk to one of us after this. We'll get you on the Oklahoma Discord. That's a very good place to get information. Yeah, Mr.
Can you guys
Smith.
talk about what CAD software you use and why, and how to get started with CAD software as well?
Yeah, so our CAD software choice is Onshape. We use it because it is very easy to do real-time collaboration with a bunch of team members. So you could have 10 people doing CAD and all of them can see all the updates in real time. Anybody with an internet connection can open it. It's really not very intensive on a computer, and it's free for education users. So
What's the name of it again?
Onshape.
It's
So
PTC. They also did Creo. It's very similar to Fusion 360. It's just like it's like the Google Docs of CAD software. This is what people call it.
where's the pen thing?
Oh, it's right here.
Okay, so here, let's get one of you guys get a link to the education website for
I
Onshape,
don't
and we'll put it up here.
You could
So
probably erase
we could erase that.
Yeah, it's easy. It's just Onshape. Just search like Onshape educational license. I would pull up a link if I had internet on my computer. I guess I could.
So the way to get started with Onshape, at least for FTC, is there are several good tutorial series by FTC teams out on YouTube. All of us come from experience with other CAD softwares, so our experience with getting started with Onshape would be slightly different from yours. But as a kind of a universal thing, there's a lot of good tutorials out there for pretty much any CAD software you can think of. So before Onshape, we used Fusion 360, which is similar. It does not have the collaborative capabilities that Onshape does, but
Fusion is good for other things that have like more intensive, like I don't know. I haven't used it in a while. They've added some interesting features.
yeah. So Onshape is the primary one.
It's onshape.com is all you need to go to, and then you can create a student account up in the upper right hand corner.
Yeah.
Yeah, it's much easier than Fusion.
So with a student license from Onshape, you get access to all the capabilities. You can't sell your designs, so don't do that. But that'll give you the full access to everything.
Also, it's important that you use a student license rather than a personal license because the student license allows you to collaborate with other people.
So what, I'm gonna take this a slightly different direction now. Once you have an Onshape license, one of the most powerful tools in Onshape is just the insert tool, because you can use libraries of parts or designs that people have already made. So for example, the meeting next door is all about Go Build It parts. Every single Go Build It part in existence is already in Onshape in the first robotics users parts library. So the way you get access to that parts library, which also has all the Servo City parts, all the Rev parts, it's got some Vex, even like West Coast. Pretty much anything you need to design a floor robot with. You send an email to first@ptc.com with all of the emails that your team members are using to do CAD. They have to match the emails that they made their accounts with. But basically, just send them an email, say, hi, I'm so-and-so, and I'd like access to the first robotics parts library, and they'll get you added within a week or so. But from there, you can have access to any of the parts, so pretty much any COTS part that you can think of. So if you're looking at the cover of one of those packets, that's a drivetrain that I designed a couple weeks ago. All of the COTS parts, meaning all of the bolts, all the nuts, all the axles and gears and stuff that come from a vendor, all came out of that parts library. It's really easy to use.
Yeah, it's also if you somehow run out of the parts that you use in the library, I did not phrase that well. There's also an FRC library called MKCAD, and that covers pretty much everything that we use except for like some Amazon and eBay parts. That's alright. Yeah. That's really powerful, honestly, like just inserting tools and being able to assemble stuff in CAD. Even if you're not planning on using any custom parts, it'll make things a lot easier for you when you go to build your robot if you design it and assemble it in CAD first. Also, like a thing with design, if you do want to use custom parts and you don't know how to use CAD, this is 4mm graph paper, which is very good because go build those on an 8mm grid, so you can design perfect 2:1 scale like drivetrains and stuff. This is also, it scales up almost perfectly to 18 inches. But yeah, so I can't recommend that enough, just to draw out stuff as to scale as possible, because then you can like mess around with it before you go into CAD, and like that can be a little overwhelming if you don't know how to use it at times.
So another thing I'll add to that is if you're able to draw and just sketch out your idea beforehand, you can save a whole bunch of time iterating through things by erasing it as opposed to undoing everything you've already done. So you can iterate even faster with drawings. And the other cool thing is if you know somebody else who can do CAD and you can draw, you can send them a sketch. You could all send me a sketch and I could translate it into CAD for you. So that's a good way to get started, is if you have an idea, you don't really know how to get it off the ground with CAD, find somebody in that Oklahoma Discord that will help you out. Because there's a lot of nice people who are really good at CAD, and all you need is a drawing to get started, so take advantage of that.
Yeah. Also, if you need, you don't even technically need this. You could just use like a ruler and like that has metric on it. Then you can also do one-to-one sketches too. Well, I mean you can almost too, but you know, drawing is really important. There are two types of sketches that we use a lot. We do concept sketching and process sketching. Concept sketching is more when you're like drawing out perfectly your design, and then process sketching is usually going to be a lot more scribbly, but it's just to figure out how to design something. So like last year, do you have the pen? Last year I was designing an intake that had a drop down, and I knew I needed a roller that was like X distance, and then I needed it to come back to a certain place. So if you draw both of those circles and then draw a circle around them, that's a great circle, I know, you can find where your pivot's gonna go. So that's just an example of like a sketch that'll help you figure out how to CAD something. I don't know if that was comprehensible really, but like, you know,
I think we get it. We've rambled a lot about getting started. but we have a panelist who has just gotten started with CAD. Jackson, do you want to talk a little bit about your experience just kind of getting off the ground with Onshape? Like, what was the first thing you designed in Onshape, and how did you get started with that?
So the first thing I designed was a 6-wheel drive tank chassis. I learned Onshape from Julian's CAD class that he was teaching over the summer. It was definitely rough at first, but once you start getting the basics, it starts speeding up and you can do a lot more.
Are there any tips or tricks that you've picked up that you would recommend for somebody who hasn't ever used CAD before?
Just like, there's a lot of things you can find online about how to do it. So just, if you find a roadblock, just go online and I'm sure you'll be able to find something that can help you.
Yeah, I would say learning how to CAD is mostly about knowing what questions to ask. Whether that's like asking yourself to figure something out, or asking the internet, or somebody you know who can CAD. The most important thing is knowing what questions to ask to learn what you're trying to learn.
I would agree with that. Does anybody in here have programming experience? Just show of hands. Any kind of programming. Okay, so in programming, what do? We go until there's a bug that has to be fixed, and then we go to Stack Overflow and figure out what the bug is, or the debug is telling us. So basically, Onshape and any other CAD system have essentially their own versions of Stack Overflow if you can find them. There's the Onshape user forum, which is really helpful because people will find all kinds of crazy problems and then have the solutions to them there. For Fusion 360, they have their own forum as well. Onshape has a really nice guide, just kind of full documentation for the entire software, which is pretty helpful, especially when you're getting started. Just kind of figuring out where things are and where to go. But there's places you can go, like Stack Overflow, if you've ever heard of that, that can help you solve problems. So another good place is the national FTC Discord, and that leads to another thing: is how do we come up with ideas for stuff to design? Oftentimes, getting inspiration from what people have done in the past is a really good resource for getting started. So going and watching old matches, going and watching FRC matches is a helpful source. Kind of forming a repository of stuff you can look at for accomplishing different things. Like later today we'll find out what the game is. Most likely there will be some kind of element that we've already seen before, which means that somebody has already designed a system for moving that element in a certain way, and you can kind of recycle that and build on it and improve it. You don't have to reinvent the wheel there.
Yeah, so then the question you gotta ask is literally just, how do we pick this thing up, how do we move it? And then all you have to do is look online for a little bit and you'll find the answer. Like, it's pretty, I guess you could say easy, but that's really just in theory. Like, it can be hard. What you gotta do is just challenge yourself during the off season, and then like, don't challenge yourself during the season, and then you'll be competitive. Like, stick to your limits, know your limits, and know how to achieve your goals within your limits. Because that's what we do. That's our problem, is that we go outside our limits. And it causes us to have issues later down the line. But
it's a good way to learn how to do things. So.
Yeah.
That's another good point, is that any kind of design presents lots of good opportunities for learning from your mistakes. So this actually leads to the design award. So for design award, documenting everything that you do all season is critically important, especially those points of failure where you made something and it didn't work at all. That's some of the most valuable things you can learn are from when things don't go right. We could tell lots of stories about that, but just try your ideas. Make a list of all the ways you could do something. This is what brainstorming is about. Is you make a list of all the things you could possibly try, and you try them, and if they don't work, they don't work, or you iterate on them until they do work. But recording those failures and learning from them is really important.
Yeah, when it comes to prototyping, I'll get to you real quick, but when it comes to prototyping, you want to make sure you're not building things that will end up on your robot necessarily, but that you can collect data from. Make sure you have like something you can adjust and like collect data from. Not that we do this very well, but like other people, or we should do this. You know, design, like, so say if there's a shooter, design a backboard that's adjustable on your shooter so that you can write down the what you get from it. Make like add weight to your wheel. Do a lot of different stuff to make sure you like know when you go back into CAD or go back to build your final robot that you know exactly what variables to enter. You have a question?
I was just gonna ask if you could just kind of roughly go through your design process. That is, you kind of start with a rough idea and then break down the different components, or do you use CAD for specific things, like you talked about intake mechanism, an arm, something that you know is gonna be specific. I mean, how do you go about laying that out?
So that is a very good question. Let's make a list, because there's an order to it. So it all starts today with kickoff. So at kickoff, as soon as we leave here, or really as soon as the video starts playing, we're gonna be brainstorming. So this means getting together with all of your team members, design members or not, because sometimes the solution to a problem can come from somebody in a completely different specialty. There's been a million times where programmers have given us a revolutionary design idea that changes the way the robot works. So anyway, brainstorming with your whole team, writing down every idea that comes to mind is really important, because if you come up with an idea and you don't test it, then you'll never know whether it works or not. So make sure not to shoot anybody down. Sometimes the wackiest ideas are actually the ones that end up being the most interesting at the end of the day. They take more time to develop, but they can be very competitive.
In 2018, the FRC game, Power Up. Oh wow, there's a similarity in the name there. That's always a good sign. No, I don't know. But my brother wanted to build a robot that basically shot these crates up onto this the scale thing. So there was basically just a big scale in the middle of the field, and then the robots had to shoot these crates up onto the scale, or they had to put the crates on the scale. And my brother really wanted to build a robot that like shot them up onto there. But everyone was like, "That's ridiculous. Why would you do that? Because come on, like that sounds ridiculous." But then the robot that actually won Detroit Worlds had that mechanism where it would like pick up the cube and shoot it up onto the scale. And it was really satisfying to watch. There was a Barker Redbacks 2018 if you're interested in that. But yeah, that was just an example of that.
Just coming back to design process, after we brainstorm, we go through and we start to make the ideas. So that begins with drawing, doing sketches to complement your idea. A lot of the time it's easier to tell what somebody's talking about after they draw it out. So making sketches is a good way to communicate with other people, and it gives you something to put right in the notebook. You can take those sketches and transfer them right away into something you can record. After we draw, we go to CAD. So when you start doing CAD, or if you've done CAD already, the first step of making a design is the sketch, which translates pretty nicely from a drawing. So if you make your drawings to scale, like Julian was talking about, it's really simple to go through and just transfer everything from your sheet of paper into CAD. You can pretty easily rough out your idea that way, and from there you can go through and refine it. But getting it into CAD so that other people can see it in 3 dimensions really helps. This is a good place to get constructive criticism in the form of a design review. So before you build anything at all, getting opinions from professionals is a good idea. And that could be like an alumna from your team who has a lot of experience with design or just has competed for a long time. It could be somebody in the field. So we'll go out and find engineers and invite them to design reviews. We'll show off our design, or sometimes we'll show off our completed robot, and we'll get their opinions on it, because it's always good to have somebody with more experience than you go back and critique your design. Getting constructive criticism is not a detriment to your ability as a designer. It really helps you grow to get that second opinion.
Yeah, I found that it's really important to take criticism as like a compliment, like, oh, somebody cares enough about this design to be like, oh, you should do this, this, and this, like, maybe I'll do this, this, and this.
I'm curious about the timeline on your design process. How does that, in terms of mapping out the time, how much time do you spend on each of those?
So we can actually break this down a little bit more. These steps happen at kickoff and really are, for us at least, happening continuously all season long. So brainstorming and drawing is going to take up all of our afternoon. It'll be a few hours today. Other days it could be 30 minutes, it could be 10 minutes, it could be 5 minutes, it could be on the back of a napkin at Worlds or something. But brainstorming, drawing doesn't have to take super long. CAD is the place that you can lose a whole lot of time really easily. So
it's really easy to waste time in CAD, because like you design something and then you just keep looking at it and you're stuck in that loop of being like, huh, that's nice, but it's not done.
The way to balance your time with CAD is to work back from your first competition. So do we get a list of when the competitions are today? Will that be part of this?
I don't know if they're going to be publishing them today, but it's essentially competitions are going to start the first weekend of November, and there will be you guys will be able to sign up for competitions November, any of those weekends except for Thanksgiving weekend. December there will be like 3 weeks. January there will be 3 weeks, I think.
Okay, so that gives us basically a month and a half, roughly. So working backwards from your first competition, you can say, we need a drivable chassis, this is gonna take X amount of time, we need an arm, we need an intake, we need this and that. And you can assign these things to different people and give them all a time budget. So we can say within 3 weeks, all of these things have to be testable. And setting that hard limit is really difficult sometimes, but that is the difference between showing up to competition with a robot that scores a few points and drives, and showing up with a robot that doesn't do anything.
Another thing with timeline is pathfinding. If you draw out all your paths and stuff, you'll know your limits a lot better. Here's an example. Last season, the fastest path was technically this one where you go in through here. And then
Time to go to next class. Sorry guys.
Alright.
Okay, thank